Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to work the question valid brackets. And what this prompt states is given a string, write a function that returns a boolean true or false if the brackets inside the string are valid. So here we have this input string where it has an opening square, opening round, opening curly, and then a closing curly, closing round, closing square. We know this is a valid bracket arrangement and would work in our code, so we return true. And now let's look at the constraints of the question. It says we only need to consider three types of brackets: round, square, and curly. The string may contain other characters, but the only ones we care about are the brackets. We can ignore all the rest. A string is considered valid if there are an equal number of opening brackets and closing brackets of the same type while also being matched. A bracket is considered matched if they appear in the correct order. That means they must be opened before they are closed and they don't overlap. So you can't have different types of brackets overlapping when the other should be closed. So let's look at some examples. We have this opening and closing round bracket. This is clearly true. And now we have a closing square, then an opening square. So this is closed before it's open, so it's false. Then we have an open, close, open, close, open, close. This is true. We have a nested bracket. We open the curly, open the square, close the curly. So this is also true. Here we have an opening square bracket, but we never close it. So this is false. In this case, we have overlapping brackets. That means we open, but then we close the wrong type of bracket first, and the curly should actually be closed after the round. This is a more complex, deeply nested set of brackets, but they're all matched and all in the correct order, so it's true. And finally, this one is nested and has multiple sets of brackets, but they're all correctly opened and closed, so it returns true. So now let's start to think through this question and try to understand what it really means to have valid brackets. So let's say we have this opening set of brackets where it goes square, round, curly, square. What would the closing brackets be? Well, it would just be a closing square, closing curly, closing round, closing square. Or the complete string would be all the opening brackets followed by that closing bracket set that we just looked at. So if we really focus in on what's happening, when you have an opening set of brackets, the closing set of brackets is going to be a mirror image of that. So if you consider this the center point, then on each side closest to the center, they must be the same bracket, and then they must match every single one moving outwards from there. So now let's walk through it character by character as if we were iterating through a string and think what we would need to have these opening brackets be validated. So we have an opening square, opening circle, opening curly, opening square. So now if we want this bracket set to be valid, well, first we would need to close this square bracket. Then we would need to close the curly bracket. After that, close the round bracket. And finally, close the other square bracket. So when you think about it like that, you actually need to work your way from the inside out. Or as you're iterating, you must close the most recent or the last opening bracket with the correct closing bracket for it to be valid. So now let's approach our example with this same logic, as if we're iterating through a string, and think why an input would be valid or invalid. So for this first case, we first encounter an opening round bracket, and then we hit a closing round bracket. We match this closing with the opening, so we know it must be true. In this case, we hit a closing square round bracket. We look for an opening square bracket. We don't find one. It's false. Here, we find the open, then the close, open, close, open, close. They all match. It's true. This one is true as well. We have the opening curly bracket. We have the opening square bracket. Then we hit the closing square bracket. We look for the most recent opening bracket. It's also square. This is true. Then we move on. The curly bracket is closing as well. We match it with the opening curly bracket. This is valid. We return true. Here we're iterating. We have an opening round bracket, opening square bracket, and then we have a closing round bracket. It doesn't match the item it should, so this is false. This is not a valid parentheses. Similarly here, we have an opening curly, opening round, then we have a closing curly. It doesn't match the most recent open, so this is false. These cases we've already seen are true, So now we have a little more intuition of what we're looking for as we're iterating through this string. So some intuition we've built up is any opening bracket is fine. You can open as many brackets as you want. The only thing that can invalidate this is if you have a closing bracket that doesn't match this most recent opening bracket. Once you have found this matching pair and prove they are valid, you can set aside both of those and then check the most recent opening bracket before that. So we keep using this phrase, tracking the most recent or the last opening bracket. What data structure is going to allow us to do that? And that's a stack. That's the LIFO functionality of a stack. The last item in is the first one you're going to use. So now let's iterate through the string again, but we've seen that we need a stack to track these opening brackets so we can see the most recent one and match it with a closed bracket when we encounter them. So we have the opening square, opening round, opening curly, opening square. Then we hit a closing bracket. So what do? We pop off the top item in the stack, or the most recent opening bracket. Then we compare it with the closing bracket. If they match, we're still valid, and we continue on. We encounter another closing bracket, so we pop off the next item in our opening bracket stack. We compare those. If it's valid, we continue. We encounter a third closing bracket. We match it with the opening bracket. We pop that off, they're valid, and we continue. And finally, we reach the last character in the string. It's another closing bracket, and it matches the opening bracket. So this is valid. And one thing to note is we used all the items in the opening set. You could have a case where you don't have enough closing brackets for all the opening brackets, and your stack has more items once you end. This will also be a false case. But here we saw, every time we encountered a closing bracket, we had a valid opening bracket, and we were able to walk through all the items and reach the end and use up all the opening with all the items that make it valid. So let's walk through the solution. We're going to build a stack of opening brackets. Then, anytime we hit a closing bracket, we pop off the top opening bracket and check if they match. If we ever find a non-matching pair of opening and closing brackets, we return false. Or if we iterate through the entire string and our stack still has items in it, then we also return false. This means we didn't have enough closing brackets for all the opening brackets. And finally, to understand how we're going to match the brackets, we just use a hash table. We do a lookup on an opening bracket and check if the value for this key is equal to the closing bracket. So the big O for this is linear time and linear space. We walk through all n items in the string. In the worst case, we're going to have a stack that contains all the characters. And now we're ready to write our solution function has valid brackets that's going to take in a string, and we check to see if all the bracket combinations are valid. First, we're just going to create our hash table so we can check the valid bracket pairs. So matching brackets. We set the key as the opening bracket, and then the value is the one that will make it valid, or the one that we expect it to match with. Then, as we iterate through the string, we'll want to see if the character we're on is a bracket. So we'll check if it's opening or closing. So let's create a set of opening and closing brackets. So the opening brackets are just the keys to our hash table. And the closing brackets are the values. And the data structure we're adding is a stack. This is where we're going to store all the opening brackets, and then when we encounter the closing brackets, we're going to pop the items off this stack so we can compare the closing bracket with the most recently added opening bracket. And here, we'll just model a stack with a dynamic array. Now we iterate through every character in the string. So for character of string, first, we check if it's an opening bracket. We know if it's an opening bracket, we simply add it to our bracket stack because we only check for valid or invalid brackets. Once we hit the closing bracket, it should match with. So if the character is included in this opening bracket set, then we know it's an opening bracket character. And then we simply push it to bracket stack. Then we also check if it's a closing bracket. And we use else if, because if it's any other character, we'll simply pass it by. So if it's a closing bracket, this is where we want to do our validation. So first, we get the latest opening bracket, or the most recently added opening bracket, by popping it off the stack. Then we see what closing bracket should match with this opening bracket that was most recently added. First, we check if there even was a latest bracket. Did our stack have anything? If not, we can't match a closing bracket with nothing. So if we didn't have a latest bracket, or our character does not equal the matching bracket. And the matching bracket means the one that the opening bracket is expecting to close with. If these characters don't match, then we know that it's not a valid bracket and we'll also want to return. So if either of these cases are true, we don't have a bracket, or the closing character doesn't match what's expected, we return false. This checks that every closing bracket matches the expected opening bracket. But the final thing we need to do is check if we have any items remaining in the stack. If there are remaining items, then that means we had more closing brackets than opening brackets and our solution is invalid. But if our stack is empty, it should return true and that everything is valid. So just return bracket stack dot length is 0. We run our test and they all passed. So we built our bracket stack with opening characters. Every time we encountered a new one, we pushed it to the stack. Then if we encountered a closing bracket character, we checked if the most recent item added to the bracket stack was valid or if it even existed at all. If it didn't exist or they didn't match, we returned false. Finally, at the end, we check if there were any items remaining in the bracket stack. If length is 0, it will return true, we used all of them, but if it's not 0, it will return false. So this is an excellent question to really dive into stacks and have one that hits close to home with programming. Thanks everyone, and I'll see you in the next lesson.